Ladies and gentlemen, okay, let's do this. Can you guys raise your hands for anyone who knows what Internet of Things is? Just raise your hands up if you've heard that term before. Okay, and keep your hands up if you actually know what it is. All right, so for the rest of you, do not fear. Sachin Pukale is here, okay? So Sachin is here to talk to you about three things. He'll answer three questions for you. He'll let you know what Internet of Things is, its marketing potential and global alliances, and why the time is now. Now, Sachin is lead business development manager with Machine Pulse. He has over 10 years of experience in product management, technology consulting, and business development. So Internet of Things is a big buzzword that's going on right now, and I'm sure everyone's going to want to know what that's all about. So without further ado, I'd like to invite Sachin up on stage. Please join me in welcoming him up on stage. There he is.
Thank you. So it's a pleasure to be here in this audience who lives on the internet, what has been told to me, and who creates basically the part of the ecosystem what's there in India. It's been created with your help. So what is internet? I don't need to talk about, but what is things? Anybody has an idea? What is things? Okay. So if you look at the evolution of internet, I'm going to talk about these topics. Anyway, if you look at the evolution of internet, computers came into existence in 1960s in the Department of Defense, and those computers were really big and were used mainly for crunching military data and communications. And then those computers moved to the universities, and the universities had access to the computing powers. Slowly, these computers were used for the electronics data exchanges where this data is stored for computation, and the mainframes came into existence. And this was available to only universities and the few premier companies. But what actually happened is the size of the computer started shrinking and it became a personal computer. That's the era of 1990s. And in early 1983, I think, if it's the exact year is 1983, where the www came into existence, and the internet started actually becoming more available to the common people. When you look at the PC era, it was 1993, 1995, when most of these web companies came into existence, and they started providing a knowledge economy to the people, where it's for education purposes, or for any other official communication, or for the enterprise users. And then in early 2000, we have mobile, and I think 2005 more precisely, where the smartphones came into existence, where Apple iPhones were launched, and the app ecosystem actually started growing. Now, where we are headed after this is like we are already here last 10 years with the app ecosystem, and apps are like billions of apps are there, but where we are headed here now is the physical things around you would get connected to the internet. Now what actually happens when this physical things gets connected to the internet is the things are able to share what's actually happening in your surrounding. Now when you can actually get this data into central location, you can analyze this data which basically get the knowledge about what's surrounding happening, and then you can actually take intelligent decisions on those data. So this term, Internet of Things, was coined actually by Kevin Ashton in MIT Media Labs when he was doing research. And he presented a paper where he said, everyday devices will have some tags which will be able to communicate to you where their presence is and what they're doing and what is their ambience and how the things around it. And that's where he coined a term, Internet of Things, where everyday devices would be connected to the internet and would start sharing the data, providing network connectivity, allowing them to send the data. And once you have the data at a central location, you can actually analyze data for some knowledge. So why actually it's happening now? It's more important. If you look at some of the statistics which were presented by the Goldman Sachs, the cost of the devices started reducing. That means a mobile phone, when it came into 1990s, it was 20,000 rupees, and that too with only basic 2G GSM communication and SMS facilities. But if you look at the smartphone phones right now, with the Android build, the phone prices have come down to 4,000 with the bigger screens, internet connectivity like 3G and 4G, and then computational power, which were not existent even in the computers 10 years back. So the cost of computing, that is hardware, is decreasing. The next more important parameter is the cost of bandwidth. I remember 2001 when I got my first computer and I had an MTNL dial-up connection. I used to get a speed of 5 kbps, 6 kbps. And now we live in a 4G world where we have 21 Mbps connectivity across, as you move. As you mobile, you have across connectivity. And the prices, if you look, it's the same price. So what's actually happening is the cost of the bandwidth is reducing. That's actually accelerated the amount of connectivity across devices. And that's what is actually taking to the next level where you'll have physical devices around you would be connected to the internet. The next important parameter is cost of processing. Again, going back to 2001, when I bought my first computer, it was Pentium 3 processor. I bought it in 40,000 rupees. It was 1.8 gigahertz processor with 128 MB of RAM. And today, we have a smartphone which has 3 GB RAM, 4 GB RAMs with 128 GB of internal memory. Forget about what you can actually extend to the external memory. So the kind of computational processing power is increasing. But at the same time, the size is decreasing. That means you have the ability to basically put the smaller devices into embed these devices into every physical things around you. The next most important thing which happened in 2005, that smartphones came into existence, and that actually is giving you internet connectivity, ubiquity to you to access internet wherever you are. And that's where actually it's becoming a gateway to internet to you. So today, if you look at the statistic, most of the people don't go to the personal computer to log into their Gmails or the Outlooks or Hotmails or to their basic enterprise task. These enterprise tasks are now brought to your device. So basically, there's the BYOD, that is bring your own device concept. So basically, mobile is becoming a gateway to the internet. And Wi-Fi connectivity, not prominent in India, it's open Wi-Fi, but let's say if you look at the Western world like Europe or US, the Wi-Fi is freely available. So let's say today you don't have to really have a GSM or 2G, 3G connectivity, but you can just go hop from Wi-Fi to Wi-Fi and you can actually get the connectivity. Imagine a device, physical device, let's say your car, it travels on the road and it needs the internet connectivity. Now, there are two options that you can do. Either you can provide internet connectivity within the car by putting a modem, or you use the Wi-Fi available services in your surroundings, wherever you move, and you keep hopping connection to connection. The next challenge was actually the connectivity. With IPv4 standards, there was limitation with 16 bits. But with IPv6, the addressable devices are increased. I mean, you can actually address up to 3.4 into 10 to the power 38 devices. So if you look at the size of the address space, it's like almost physical device on this earth. You can actually give one single IP address. And hence, basically every device would get an identity on the internet when they get connected. Other things actually happened parallelly in the ecosystem is the cloud computing. This is becoming now mainstream and it's coming to, every enterprise and every individual using Dropbox, Box and other services on the cloud. At the same time, big data tools were made available. That means like Apache, Hadoop, Sparks, and Storm. Such kind of tools to digest the incoming real-time data were not available 10 years back. So these tools are... So what's happening right now is all these things are coming in place together at this point, and this amalgamation actually is giving you a platform where you can actually extract the amount of data that is available to you. And obviously, going forward, the artificial intelligence would come and play a bigger role. So let's look at some of the market potential. This is a report published by McKinsey & Company in June 2015, where they talked about the economy size or the potential from the IoT market would be between 3.9 trillion to 11.1 trillion by 2025 every year. When we talk about these numbers are really big. But what actually we need to really realize here is these numbers are not the real benefit which goes into pocket. Some of the benefits are the soft benefits. I'll talk about it in some time. Let's look at some other survey or the research conducted by Cisco in 2013. What are the numbers they're talking about? They're talking about asset utilization, market opportunity available is $2.5 trillion. I'll give you one example and try to cover this aspect. Imagine you're traveling in your car and coming to this conference. Let's say you're coming from Powai and your car breaks down at, let's say, Seebs. You don't have a clue what's actually happening in your car. But then what do? You call, you look out the nearest mechanic, you call him, and then he tries to come and looks at the car, he opens the bonnet, probably just try to see if the engine is working fine and everything. But then he realizes there's a problem, there's a temperature indicator that has actually come. Now what if you have a mobile phone which gives you an alarm before you start from your home that your car probably would break down in another hour or so because of this possible problems. What you would actually do is, you could go to the nearest mechanic when the car is functional, you could show him this is the status, what car is actually predicting that it would fail down in the next 1 hour, and can you just check. What actually happens is, your asset utilization, that means your car's availability has increased. Now because of a breakdown at a seeps, probably you'll spend 1 hour, 2 hours just getting the car repaired. Your availability of the car has gone down 2 hours for the day. What's actually losing out you is on a time, and then you have to pay a significant amount of money to the mechanic to repair your car. Now this repair, if it is only, let's say, some kind of a resetting an error or just kind of just taking out the connector or rebooting a system, it's okay, it's not something that is. But imagine if you have a temperature related issues where your engine is going to actually overheat up and finally it's going to break down. What actually probably you may end up is lakhs of rupees of maintenance cost or probably the repair cost. Now if let's say you have a smart device which actually sits into your car and gives you advanced notification that probably your engine is heating up since last 30 days and there is a temperature related issue or that your engine oil needs to be changed. Even if your engine oil date is 1 month down the line, but the quality of engine oil that is used is not good and probably you need to change, you could save that 1 lakh of rupees. So what you actually save is the time, you save money. So, and in this process, you basically increase your asset utilization. So what Cisco identified is, globally there is opportunity to basically capitalize on $2.5 trillion in next 10 years going forward. Employee productivity. Now let's say, move on away from this car example, from personal car to let's say Uber car, or let's say Meru. Meru has their own fleets. Now imagine if the Meru has thousands of cars across Mumbai, and they really need to track how their cars are actually working. How do you do that? I mean, they cannot do it manually, so they need to have. So basically, let's say they wanted to, let's say, track the productivity of their employees, how their actually drivers are doing, or how their basically cars are functioning on the roads. They need some kind of a connectivity to their cars or basically drivers to know how they're actually employed. Now, when you talk about the employee productivity, it's also that how much a driver can drive a car per day to maximize the income from the available assets. Now, imagine you own a car and you, let's say, have a company which is a car renting company and you rent out the car. Now, let's say the first situation we identified, okay, your car is going to break down, so you increase your uptime of the car by using the asset utilization application, basically, the smart car application. But what if your employees don't know how to read that thing and then apply that knowledge? If there is only fault which can be resetted manually by your, let's say a driver is driving a car and he sees there is on the dashboard, there's a red light just comes up. But he doesn't know when that red light comes because he's not trained to maintain the car. But what if a mobile application actually gives you indication and the quick fix process? Okay, before you take it to the mechanical, you can actually do this 2 steps, so you can still run for an additional 10 kilometers. This way, actually, you, obviously increase your uptime of a car, but you can probably, if you have a customer or probably an employee who's driving the car, he can actually continue for some time, and then he can actually take it to the mechanic to basically sort out the issues. The next thing is supply chain logistics. Again, there are maintenance issues, customer experience. Finally, if the car breaks down, actually the customer is going to get the more pain. And then finally, what's actually happening is your brand identity is at a stake. The values are at stake. Probably they will feel that A company cars are not good, so probably I will not go with that company cars next time. And finally, how you can actually innovate. So basically, Cisco identified there's a 14.4 trillion market opportunity out there where that can be capitalized across these 5 verticals going forward in 10 years. So Cisco, when they also did this research, what they found is globally, if there are 100% of things available, only 0.5% of things are actually connected to the internet today. That means what they realized is there are total 1.5 trillion things that you can actually connect to the internet today, and only 0.5, that is 10 billion devices are actually connected to the internet. This significant opportunity exists today for the entrepreneurs to start looking at this area and start connecting things to the internet. Now, what are the applications that actual use cases that you can think about? Is the smart grids, connecting energy meters, water meters, gas meters to the internet and collecting data and providing, using basically the optimum way to operate your grids. Smart buildings, again, energy management, there are avenues available in that area. Connected healthcare. Imagine a patient remotely can be diagnosed and then being provided ambulance service early on to basically, if you can save his life, there's a tremendous opportunity in healthcare. So there are multiple opportunities in the commercial, vehicles, cars, and automotive segment, particularly connected marketing and advertisement. Advertisement been using internet quite often. We've talked about there are like cookies and other things been already there. Now, what if, let's say, you are traveling today and there's a dashboard which shows you the ad for what you were looking on the Flipkart on the other things. So that just makes your buying decision more when you visit a mall. So there's a connected advertising that can be benefited from this IoT market. So when we look at the India private sector opportunity, so what is the opportunity? So Cisco, when they did research, they found almost $400 billion, close to $394.8 billion opportunity exists only in the private sector in the next 10 years. And those opportunities lies in these various verticals like smart factories, and then smart farming. Agriculture is the biggest area that's going to get benefited from this. When you look at the public sector, what is the opportunity? So there's a $116.2 billion opportunity in the public sector, whether it's from the e-governance point of view, digital India point of view, or there are various other, like providing the right services to the audience, your citizens, talking about the traffic management, and there are various other facilities can be extended by the public sectors to the citizens. And this opportunity is almost size 116 billion. So when we talk about India, in next 8 to 10 years, we are talking about something like $500 billion opportunity being created with IoT in India. So what are the applications? There are multiple applications. There's a Liblem Smart World. You can just refer to this. You can just search on the Google, and you'll be able to like just go through the document, like what all application you can look at and what you can actually try to build with this. So let's look at some of the use cases that has been in existence in world since last 5 to 10 years. How many people know about Waze? Okay, it was an initiative started in Israel in 2006, where a few people came forward and wanted to create a map of Israel, which is open source map, can be used for community services or can be used for any other non-commercial uses. But what they realized is, when they started this crowdsourcing efforts, they realized there's a tremendous benefit with this crowdsourcing information. So what they did is, they created an app. I'm sorry. Okay. They created an app which gives you the best way to a location. So let's say every day you start 8 o'clock in the morning, you go to the office, you wanted to reach at 9 o'clock, so there's a way fixed. But what if, let's say tomorrow at the same Seep junction, there's an accident happened, and then there's a huge bumper-to-bumper traffic. So this application, what they did is, they provided an interface to every user on smartphones that if there is an accident or there is an incident, you can report that incident into the smartphone in the real time. And what they do is, every user who switch on this application would get notified for this incident if they're traveling on this road. So what they would do is, they'll collect this information in real time from their users, and they will provide this knowledge in a collective manner to the rest of the users who are traveling that road. So let's say if there is a heavy traffic on, let's say, road from Powai to Andheri, they would reroute the traffic via some other route, so the people can reach to their destination in time, and the congestion at a particular point in the city is avoided. Going forward, people started using, so everything which comes for a good, the bad comes along with it. So there is the internet for good, and the internet is also used by the bad people. So what actually happened is, people started using this application to notify where the cops are standing on the road, so you don't need to drive, and then you will not get the ticket for overspeeding in those areas. So what actually happened is, people drive faster, and people, when they see the cop, they will put into the application, the cop is standing at this corner, so please slow down. What actually happens is, every user who's driving on that road gets to know, okay, there's a cop standing on that side, so I don't need to overspeed, otherwise I'll get the ticket. But then there's a side to it. Google acquired Waze in 2013. Now, what actually we can do with this app, people wanted to use it for the negative use, but let's say you see the drivers are driving on this particular point, A to B, overspeeding, let's say 100 kilometers per hour, 100 to 20 kilometers per hour, which is more than that. Google, let's say probably going forward, how they can make this life safer for the drivers who are using this app, besides getting the distraction from the app, is probably they can simulate a cop and they can put a cop at a particular point. Imagine I'm driving at 120 kilometer speed, which is not actually good for me because I'm going to lose control in some time. Now, if the application probably can analyze my driving pattern, and if they can actually simulate a cop position, which only alarms me to slow down my car, is going to only give me safer ride, and probably the accidents could be reduced. So it's only we need to see going forward how we can actually use technology to basically have more safer world. So Waze provides you basically collecting data from your smartphone sensors. So here, when you talk about a thing, your smartphone becomes a thing, and then provides you the right services, whether to get the best routes, provide other real-time help from the other drivers, and other things. There are a lot of applications, which is like hot application, the smartphone, smart homes era, where Google and Apple is coming up with their own suite of home kits, and then their own suite of Nest products and other things. What's actually happening in this area is your home is going to become kind of an assisted living. That means your home would become smarter to give you better living experiences. That means if you're going home in a summer where the temperature is 40 degrees centigrade or 35 degrees centigrade, your home will know that probably you're arriving in the next 5 minutes or 10 minutes, your ACs would be switched on, and by the time you reach your home, the ambience temperature would be around 23 degrees, so when you enter, you're going to get a pleasant, and the music would be switched on and other things. There are a lot many companies are trying to innovate in this space. This is quite a hot space across globe in the Western world, and also in Indian companies are trying to innovate in this space. This is a very particular example from our own India and from our own Mumbai. This is the company called Chetas. Now, what this company is actually trying to innovate is a smart meters for a water segment. We've seen pipelines get burst, and then by the time the municipality or the BMC gets the notification, already you have lost thousands or probably lakhs of liters of water. So this company is trying to do is monitor every pipeline, let's say at few kilometers and few meters. And then if there's a breakage or there's a change in the flow pattern, they're going to notify the authorities. Okay, there's a change in this. These meters could be also used for the billing. So let's say your home, you have a utility meter which gives you water. So every month, a water utility company person would come and probably record a reading. So there's a manual method which is used to basically collect. The smart meters actually could communicate to the internet back and give you the reading in the real time, what's your actually consumption of the water. So there are two examples. One is from the leakage side and then saving the resources. Second thing is on the employee productivity, where your employee has to travel every month to get the meter readings. That can be avoided, and the meter readings can be collected. So the bills can be processed quite fast. Imagine if a water resource assessment takes, let's say, or the billing or data collection takes, let's say, 10 days, bill processing takes another 5 days, and then the bills are dispatched after 15 days, you receive a bill after 25 days after getting the meeting readings for your 30th. So probably you receive a bill only after 20-25 days. And what actually happens is after you receive a bill, your water authority have to give you some time, like 30 days additional time to basically pay you the bill. So what actually happens is you have used water, but you are paying for the water consumption or the water use only after 45 days or probably 50 days. So the amount of collection that you're actually, the water authority is losing is money they're collecting after 50 days. The third advantage could be if they can dispatch a bill in 1 or 2 days, they'll be able to collect money faster. So actually what happens is, on the first aspect is leakage, second is employee productivity, third aspect is improving on your efficiencies and your profitability actually. So what is IoT system components? So we have looked at some applications, let's say, and let's say tomorrow you wanted to build a IoT product, or let's say we wanted to build some services around it. So what do you really need to have? You need to have some kind of a devices to whom you wanted to provide intelligence, and you need to have some devices which will collect the data from the physical devices. Let's take an example. You have an air conditioner or let's say a refrigerator in your house, and you wanted to collect, let's say, temperature data and the humidity conditions in your refrigerator, so your food which is stored in your refrigerator don't get rotten actually. So what you do is you need to have some connectivity aspects. So you have some sensors which goes and gets connected to your refrigerator. This sensors collects the information and gets connected to your Wi-Fi network in your house, and then this communicates to the cloud or your application server over MQTT or HTTP. MQTT is a message queuing a protocol which is used in the IoT world quite often. HTTP is quite a common protocol standard used basically to communicate over internet. Further, this data goes into the cloud where it gets aggregated, analyzed, there's a rule engines which gets applied, event processing is done, analytics is done, where let's say if your temperature of the refrigerator goes, let's say above 15 degrees, which is the set temperature, you'll get a notification and other alarms. So those could be on your web portals, could be on your dashboard, or could be delivered to your mobile through API notifications. So this is basically a system components broadly that you need to have if you really wanted to develop something into the IoT world. So what are the sensing options available to you? You can sense temperature, humidity, pressure. There are multiple things available that you can actually sense. When we look at communication aspect, what are the communication aspects available? We have smartphones which are enabled with Bluetooth and Wi-Fi. Some of the smartphones are available with NFC tags, but NFC is not common. But Bluetooth and Wi-Fi is what, if you're, let's say, looking at developing some application in the consumer world, I would suggest Bluetooth and the Wi-Fi are the best communication protocols or basically the physical mediums to basically go ahead with. But if you're looking at some of the industrial applications, then there are various others like Zigbee, there are others like LoRa for the long-range wireless area, wide area networks, and there are multiple other options available for the communications. Now you're able to collect the data from your refrigerator and you pass it on to your, let's say, through communication channels. And finally, you need interface where you have a cloud infrastructure where you collect this data, store this data, and analyze it, and then finally further process it and make it available to the user in a right dashboarding manner, where user can actually get the insights into the data. So how it actually looks when we talk about the IoT going forward, are we looking at this kind of a scenario where everything gets connected to the one big computer like IBM's or Cisco's of this world? Not really. What we really see is the network is going to be common. We are going to use internet, but what actually happens is all these applications would come into the silos. And that's where the challenge is. If, let's say, you have a car and that car needs to talk you to your home, how it's going to talk? And that's where the standardization practices comes into play. Because if you don't have the standards in place, your car talks in English and your home talks in Hebrew or in Mandarin, and they won't be able to talk to each other. So let's say if you're driving home, your car needs to tell your home devices that I'm coming home, so please switch on AC or please start a tea maker machine or something or the other things. But if, let's say, these things are not able to communicate, IoT is not going to come into existence. So let's look at some of the constraints. First is when you talk about IoT, you need to have low power devices. Why low power? Imagine you have a, let's say, temperature sensor which you actually put into your house. You cannot afford to charge batteries every day like what you do with the smartphones. Smartphones we do because we don't have an option. But let's say if there's a temperature monitoring device and you need to charge every day, you'll get fed up with it. You'll say, okay, I'm not going to charge after 3 or 5 days. There's an interesting example in the wearables side. There are a lot of health trackers actually coming where you can wear a wearable band and you can go around. There's a visible trend where people buy these wearable devices. The intention is right to basically use it every day. But what happens is these wearable devices needs to be charged every 3 or 4 days. Some of the good devices charge every 15 days. And that becomes kind of a hurdle. People don't want to charge these devices every 3 or 4 days when they don't see real immediate benefits. And that's where when you design an IoT system, you need to think about very low power systems. So that means if you put a battery into it, you should forget it for 1 year or 6 months kind of a timeline. And you don't need to really think about it. Second thing is the low bandwidth. Why low bandwidth? Is because if you have, let's say, multiple devices talking and sending gigabytes of data every day, your bandwidth is going to get choked up. So if a temperature sensor, you're designing, let's take a simple example, if you're designing a temperature sensor for your home, you don't need to send temperature data every second. If there's a temperature change, then only you send the incremental value in the change. So you need to design your devices so it's a low bandwidth. This also actually saves on the bandwidth and on the bandwidth cost. The next thing is support for the mesh technology. This is nothing to do with the IoT's whole ecosystem, but when you look at the type of the interoperability, or you wanted to have a communication between A device to B device, you need to have mesh networking stack supported in your devices going forward. The major constraints going forward are the security. We have seen today morning how the security has been breached and what can be done actually. So imagine today when you have cameras, we have already seen a webcam being with the help of a Trojan hacking, probably people are able to see the 24/7 CCTV cameras or web cameras. There are baby monitors are used in the Western world today. Now imagine if these baby monitors, which are the things, these are not connected, these are not like a webcam, but these are a physical camera which is put in your house basically just to track what your baby does in the day. Now imagine this can be hacked. It could be a serious issue, or it could be a serious security threat to your family. So security is the most important aspect when you design any IoT application. Data privacy, I don't need to talk about it. It's your private data. So whenever you basically sign up with any Googles or any other companies, or you design your own solution, you need to think about your customer's data privacy. How you're going to save his private data. Because when he connects, let's say, his home or his car to your portal or your services, he's actually sharing your data, his data with you. And if this data can be hacked, it's going to be a serious threat to his personal life, probably, or probably other. It could be used for any other purposes. And the most important part, besides security and data privacy, is interoperability standard. What if, let's say, you design a system today and it becomes invalid 2 years down the line? Imagine we are using internet successfully because everything works on a standard. There's a HTTP standard, the way that your web browser talks to your server, the way your server gives the web page to your browser and it loads. It all comes to the proper standards. Tomorrow, imagine if I made a website into some other language and I ask you to go through and just check it. It's not possible for you to check any website actually through any standard browsers. So internet is successful, I would say, is only because of the standardization. And what's actually happening is, when the IoT is coming into place, everybody wanted to push their own standards into the market and say, okay, this is the best standard to use. So today, when you actually design something, you need to look for a right standard. If you don't select the right standard, probably you will become obsolete in next 2 to 3 years. So your amount of investments that you do in your IoT application would become null and void after 2 years. So you need to be very careful when you look at the interoperability in the standards point of view. So when we talk about the standardization initiatives, there are some of the initiatives. At the top, those are the initiatives more on the physical world, which are controlled by like Bluetooth and the Wi-Fi and the IEEEs and the Zigbees. These are more on the physical world where they provide a connectivity, physical layer in the OSI layer, and then the network layer. As we move upwards, there are IETF, OSS, and OMGs of the world who are giving you the standards, how your IP-enabled world is going to communicate. And once we come above, the third level in the standards, where you have All-SYN Alliance, 1M2M Alliance, which gives you the standard ways of communicating at application layers. So when you look at the IoT, you wanted to make an IoT products, or let's say you wanted to start IoT services, you need to think about these standards to follow. You just cannot pick something from the market that you feel, okay, it's a low cost or it's easy to make, but you need to think probably when you put this device in the market, how it's going to communicate with the rest of the other devices in your home or in your enterprise applications. And then there are a lot of industrial standards, like the first three things are more overlapping between your consumer and industrial side, but the fourth layer is more targeted towards the industrial side, where you have industrial consortium, which is led by the GE, and it's a consortium which is making efforts to basically standardize the way application can be configured in the IoT world or industrial IoT world going forward. So let's look at some of the Indian ecosystem. So when we look at in India, there's a lot of buzz today about IoT, but people are clueless where to start. So there are a lot of actually small startups that are trying to innovative. Like Gecko came up with a small Bluetooth device which can be used for the tracking purposes. It's like a find me kind of a track or tag which you just put onto your any luggage, and if let's say if you lose it, your mobile gives you a notification you are out of that range that you may lose your luggage or your bag or your probably valuable items. This PlugX is a company from Bangalore which is trying to do something in home automation space. Machine Pulse, Magnet Works are the companies trying to do something in the industrial IoT space. Chetas, we have talked about into the water metering. ShopSense is trying to do something innovative into the retail space, where they're trying to basically create an online presence, the online experience when you go to the retail store. So there's a dashboard or there are displays on the where you can actually try out various clothes, you can see your sizes, what fits best to you, what doesn't fit best to you, and those things. And then finally you select one, and only that dress is actually shown to you, or that shoes are only shown to you. And you don't have to go and try out, let's say, 10 different shirts to basically what fits best to you. And there are other big companies trying to innovate in this space, which would be mostly system integrators going forward. They're quite active, like Wipro, Tatas, L&Ts, and of the world, iGets and all. So where we are actually headed, Prime Minister has talked about Digital India, and we have heard today morning, where Prime Minister envisions every farmer or probably every Gram Panchayat in our country, which is like 250,000, would get connected to the fiber network. Now what happens then is, the internet connectivity is available to every farmer in every village. Now imagine today, if you can actually share knowledge that how agriculture can be improved with a less of a water by using some technology, it would actually help improve the agriculture, improve the yield of your agriculture and probably have more resources basically utilized in the right manner. Today what's actually happening is, even if the agriculture is there, the land is available, water is available, but then we don't know what is the right mix of the fertilizers to be used. There are means and other things, but if we get connected to the internet with the right sensors, we can actually check what is the soil moisture, what is the fertilization levels required in the soil, and we can give you exact advice to the farmers. Probably you don't need fertilizers in, let's say, this much quantity, but this soil condition, only this much fertilizer is required. So you don't need to overdose your soil, because overdosing also kills your soil's ability to basically grow proper crops. So it's more important. So going forward, I see there's a revolution coming into the agriculture space where every farmer would be able to use the technology to basically grow more crops. Healthcare is another initiative which Government of India is trying to bring, where the low-cost healthcare could be provided to every citizen of India. There are a lot of startups actually trying to do, where the model would be, you don't need to be a doctor to provide the basic services. Let's say if a mobile-based application and some small hardware which can do your basic ECG and basic test in a remote village where a doctor and ambulance cannot go. If you can have a hub and spoke kind of a model, every taluka will have few people will be trained on this technology. They can go to the nearest village, can provide the basic healthcare to the rural people and then analyze their pattern and then collect the basic trivial healthcare information on mobile. And once this is available on the mobile, can be shared to the doctors or the prominent doctors available in the Mumbai cities like Mumbai, Delhi, or even to the foreign universities. And then finally provide through e-healthcare, through provide, let's say, medicines and other prescription through e-internet to these rural people. So this is another, field that I see a lot of innovation can happen into this area. Indian government is also, talking about IoT very seriously, where they published a paper last year in 2014, October 2014, where they proposed a model where actually industry and academy can come together and there can be an ecosystem that can be created to basically capitalize on $15 billion market. This is the figure that is given by the Government of India. The figures which I talked earlier were given by the private research conducted by the private companies. So Government of India is talking about the market in India of $15 billion in next 6 years. When that's like something like 2020, we'll be able to capitalize, basically the opportunity available to is $15 billion. So thank you. Thank you for listening to me. Any questions? Probably I can take offline. Thank you.